Previously, we have defined smooth manifolds with boundary. These are second-countable Hausdorff's topological spaces that are locally homeomorphic to the upper half space in such a way that the transition functions are smooth. Now, for such a manifold, with boundary, not all points are created equal. So we want to distinguish two types of point, the interior point and the boundary points. So let's first talk about the interior and the boundary of the upper half space itself. Recall that the upper half space in Rn is just a space of points whose last coordinate is greater than or equal to 0. So we define its boundary to be the space when xn is 0, and then its interior is going to be the space when xn is strictly greater than 0. We use these two notations interchangeably for the interior. Now, so those are the interior points and boundary points of the upper half space. Now, how about for a smooth manifold with boundary? Let M be a smooth manifold with boundary. We say P is an interior point of M if under some chart it's going to be mapped to an interior point of the upper half space. And similarly, we say Q is a boundary point of M if under some chart it's mapped to some boundary point of the upper half space. Okay, does that sound good? Well, you probably feel a bit uneasy about this. How do we know this is well defined? What if P is mapped to an interior point under one chart, but then it's mapped to a boundary point under another chart? The good news is that this cannot happen, because any diffeomorphism between open subset of the upper half space must send boundary points to boundary point and interior points to interior points. We will discuss this in the next video.